Now in this video we are going to take up one more problem on projections of laminas. How to analyze this problem and solve by using the sketchbook. The problem reads as a pentagonal lamina having edges 25 mm is placed on one of its corners on VP such that the surface makes an angle of 30 degree with VP and perpendicular bisector of the edge passing through the corner on which the lamina rests appears to be inclined to 30 degrees to HP. Draw the top and front views of the lamina in this position. Now to do this, so first we will go for the initial position. Since he says that the pentagonal lamina is resting on VP, so obviously we have to start the problem from VP. So that means it should be from the front view. So initially I am going to keep the lamina in space such that one of the perpendicular bisector is parallel to VP. So why? Because that perpendicular bisector should be able to get the true length in the vertical plane. So now if we keep that A, that is the corner position A, B, C, D, E, and this is the perpendicular bisector what we are talking about, AM. So this perpendicular bisector is parallel to VP and also parallel to HP. But the surface is parallel to VP, but it is perpendicular to HP. Since it is perpendicular to HP, you are getting a line in the horizontal plane. When you look from the front view, since it is parallel to VP, you are getting the true shape in the vertical plane. So all the sides A, B, C, D, E and AM all are parallel to VP. Therefore, every side is in true shape or true length in the vertical plane. As you look from the front view, you can see a pentagon of 25 mm sides, okay, and this perpendicular bisector A-M. So what is that perpendicular bisector? Joining between the corner to the opposite side midpoint is the perpendicular bisector. So this perpendicular bisector is parallel to HP, and here this perpendicular bisector is parallel to VP. Since it is parallel to VP, you are getting the true length in vertical plane. Since AB is parallel to VP, therefore you are getting the true length. Since BC is parallel to VP, so you are getting the true length in the vertical plane. CD is also parallel to VP, you are getting the true length in the vertical plane. DE is parallel to VP, so you are getting the true length in the vertical plane. EA is parallel to VP, so you are getting the true length in the vertical plane. Since all the sides are true length, therefore it is in true shape. When you look from the front view, this pentagon will be projected onto the vertical plane. When you look from the top view, since it is perpendicular to HP, you are getting the line. As you look from the front view, A dash, B dash, C dash, D dash, E dash is visible and M dash is also visible. When you look from the top view, ABC is near to the observer, so ABC is visible. MDE are always invisible. So this is how you will be able to analyze the initial position of your problem. What is the surface? What is the position of the surface with respect to both HP and VP means it is parallel to VP and perpendicular to HP. Since it is perpendicular to HP, so you are getting a line in the vertical plane. So how to draw this now? First we are going to draw the XY line and you mark VP and HP and with the XY line. So first initially in the front view you start creating a pentagon. How to start creating the pentagon? Draw a vertical plane, vertical line, and you measure the distance from you mark these 2 points. You mark these 2 points, which is 25 mm. You mark this as C dash and D dash. Through C dash by holding the with respect to C dash D dash, you measure an angle of 108 degree in the clockwise direction with respect to this sector C dash. Then draw an inclined line. Similarly, from D dash also you do the same thing with respect to C dash D dash. You draw an inclined line which should be 108 degrees to this vertical line. So by using the compass, you measure the distance. Take the 25 mm with C dash as center, cut an arc on this 108 degree line. Similarly, with D dash as center, cut an arc on this 108 degree line. And you mark these 2 points as B dash and E dash. Then through E dash, you take a 25 mm and draw an arc Similarly, with B dash center cut on the previously drawn R. You join the diamond, you join them with A dash, B dash, B dash, C dash, C dash, D dash, D dash, E dash, and D dash, M dash. So then one of the perpendicular bisector, which is that A dash, M dash, which is parallel to HP. Since it is parallel to HP, so you are getting the true shape in HP. True length in HP. Since all the sides are parallel to VP, therefore in vertical plane you are getting the true shape. So this is how you will be able to analyze in 2D. Now I need to rotate this, which is the surface is inclined. Initially, what is the inclination of the surface with respect to VP? The inclination of the surface with respect to VP is 0 degree because it is parallel to VP. But now what he says, the surface is inclined to VP. As we rotate this in space, then what happens? This will going to be the inclination, that is A dash M dash. That means the line is parallel to HP. Since it is parallel to HP, so I am getting the true length. Since that A dash M dash is inclined to VP, why? Because the surface is inclined, automatically that A dash M dash is on that vertical plane, on that surface. Obviously this A dash M dash will also be inclined. So now when you look from the front view, this A dash M dash will be in apparent length. So it will not be in true length because A dash M dash is inclined to VP, because the surface is inclined to VP. So then as we look from the front view, all these points are being projected onto the vertical plane, and you mark those points as A dash, B dash, C dash, M dash, D dash, E dash, and A dash, and then join them A dash to B dash. So now when you look from the front view, the image will going to fall on the vertical plane, which is A dash, B dash, C dash, D dash, E dash, and A dash. And here A dash, M dash is in apparent length because this A dash M is inclined to VP. Since it is inclined to VP in vertical plane, this will not be in true length. But what is the position of with respect to the top view? The position of the point with respect to the top view, which is as shown here. ABC is near to the observer, so ABC is visible. M, D, E, M, that is D, M, and E are invisible. So therefore, you have kept it in bracket. So this is how you will be able to analyze this. Now I need to write the solution. So what I need to do, take any convenient distance from the first position front view or top view, and you mark a point on the XY line because one of the corners is on VP. So then what you need to do is you need to measure by using the compass. You measure an angle of 30 degree with respect to this XY line with A center and draw an inclined line. Then you measure the distance from A to C with A center, cut on the previously drawn line. You mark that as C, then D in bracket, then M in bracket. Similarly, then join between A to C. Then you measure the distance from A to B of C with A center, cut on the previously drawn arc, and you mark these points as B bracket E, then C bracket D and bracket M. So once you do that, so now you got the top view such that the surface is inclined to VP. So now for this position I need to write the front view. So how to do that? From A you draw a vertical projector to the front view. From A dash you draw a horizontal projector. Both these 2 points will going to intersect at this point, and you mark that point as A dash. Similarly, draw a vertical projector from B and E to the front view, and draw a horizontal projector from B dash and draw a horizontal projector from E dash. These 2 lines will going to automatically intersect at this line which has been projected from B and E in the second position top view. Then draw a vertical projector from C, D and M to the front view, and draw a horizontal projector from C dash and then from M dash and then from D dash, and you mark those points as C dash, M dash and D dash. Now this will going to be A dash M dash is the perpendicular bisector of the edge passing through the corner, will be appears to be inclined to VP at 30 degrees. As the surface becomes inclined, since that surface, since the perpendicular bisector is on that surface, obviously that surface is also being rotated. So what is the position of that point? Now here A dash M dash will not be into length because it is the apparent length. Always this A dash M dash will be less than this A dash M dash. In this case, AM is parallel to VP, so you are getting the true shape here. But since this line is inclined, that is A and M is inclined, obviously this will not be in true length, it will be less than the true length. Then he says the perpendicular bisector passing through the edge on which the corner rests appears to be inclined. Appears means what? It is apparent inclination. So since it is apparent inclination, therefore the length what you got in the front view is apparent length. Then you rotate this such that the second position surface which is in space being inclined to VP. And when you look from the front view, all these points are being projected onto the vertical plane. So one should do that. To this, when I write the top view, take the projections from the second position top view such that you will going to get the square, this pentagon in the horizontal plane. That is by looking from the top view. So this is how you will be able to analyze it. And now how to solve this problem. So what to do? You take any convenient position and mark that point and draw a horizontal line. With that as center, with reference to the horizontal, you measure an angle of 30 degrees and draw an inclined line. Then I want to reproduce the same sketch here at 30 degrees. So you measure the distance from A dash to M dash with A dash as center, cut an arc on that 30 degree line and you mark that point as M dash. Then through M dash you draw this vertical projector. So by taking the protractor to the M dash center and with reference to this A dash M dash, you measure an angle of 90 degree and draw a line perpendicular to A dash M dash. Then through M dash, by using the compass, you measure the distance from M dash to C dash with M dash as center, cut an arc on that inclined line which is drawn perpendicular to that inclined line. Similarly, you extend on the other side, then you measure the distance from M dash to D dash. From M dash, you cut an arc on this and you mark that point as D dash. Then join C dash D dash with a dark line. Then I need to measure the distance from A dash to this point. Then from M dash, you cut an arc on this inclined line which is A dash M dash. And through this point, you draw a perpendicular to this A dash M dash line. Then you measure the distance from this point to B dash, which is same as from this point to E dash. Then through this point, you measure the distance from this point to B dash. From this point, you cut it on this perpendicular line. Similarly, you measure the distance from this point to E dash with the same point as center, cut an arc on this line. So you mark that point as E dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and E dash to A dash. And then join A dash M dash with a thin line. So this is how you will be able to write the third position front view. As we see that the surface becomes inclined, since that perpendicular bisector is on that surface, therefore A dash M dash will also become apparent length. So since the given inclination is apparent inclination and the length what you have got from this is second apparent length, so you can transfer it directly and then reproduce the same sketch here. How to do that? With A dash as center, you measure the distance of A dash M dash with any point on this center, cut an arc on this 30 degree line, you mark that point as M dash. Then similarly, you measure the distance from A dash to this point and transfer it from A dash to this line. And through this point, you draw a line perpendicular to this inclined line. Similarly, with M dash as center, you draw a line perpendicular to this 30 degree line. Then you measure the distance from this point to E dash, which is same as from this point to B dash. With this point as center, cut an arc on this perpendicular line. Similarly through E dash. Then name them. Name them as A dash, B dash, C dash, D dash, E dash, and then M dash. Then I need to write the top view now. To do that, draw a vertical projector from A dash and draw a horizontal projector from A. Both these two lines will going to intersect at this point. You mark that point as A. Then draw a vertical projector from B dash and similarly from E dash, and draw a horizontal projector from E and B, and you mark this point as B and you mark this point as E. Then similarly you draw a vertical projector from C dash, then D dash, and draw a, then what I need to do, you measure the distance from I want this line. You draw a horizontal projector from C dash, okay. Draw a vertical projector from A to the XY line, you mark that point as A, and draw a vertical projector from B dash and D dash, and draw a horizontal projector from E and B, and both these two lines will going to intersect at this point. You mark that point as B and you mark this point as E. Similarly, draw a vertical projector from C dash and also draw a vertical projector from D dash and draw a horizontal projector from C and D, and you mark these 2 points as C and D. Then join A to B, B to C, C to D, D to E, E to A with a dot line. This is how you will be able to analyze and solve this problem in 3D, and also how to write it in a sketchbook. So once you do that, how do I know that this problem is right? I can see the one of the perpendicular bisector passing through the corner on which the lamina rests appears to be inclined. So once this inclination, once this surface become inclined, so the perpendicular bisector is also becomes inclined. So once this perpendicular bisector becomes inclined to BP, then you are going to get the apparent length. So directly, so since it is an apparent length, therefore you can rewrite the same sketch here. But and here the corner is resting on VP, so you can see that even in the final position the corner is resting on VP. In the second position itself, the corner is resting on VP, such that the surface becomes inclined to 30 degrees. And this is a pentagon of 25 mm side. Since all the data which was given in the problem has been able to be considered to solve this problem, and hence our problem is right. Thank you.